Hi student, this is Sivakumar. 10th standard mathematics chapter number 7, continuation of exercise 7.4, no problem number 5. Sinu's house has an overhead tank in the shape of a cylinder, cylindrical overhead tank. This tank is filled by pumping water from a sump. Sump is in underground, which is in the shape of a cuboidal shape. The sump has the dimension of 2 meter into 1.5 meter into 1 meter. Generally, we consider them as LBH. You know that volume of the cuboid is LBH, length 2 meter, breadth 1.5 meter, and the height is 1 meter. The overhead tank has its radius of 60 centimeter and height 105 centimeter. Find the volume of the water left in the sump after the overhead tank has been completely filled with water from the sump, which has been full initially. Here we have problem number 5. Cylindrical overhead water tank and sump. It is an underground. It's an underground tank. It is in the shape of a cuboid. So dimension 2 into 1.5 into 1 meter, I consider them as L, B and H, length, breadth and height. Look at the units, all the units are meter here. But overhead tank radius is given 60 centimeter. Look at the unit centimeter. You have to change either centimeter into meter or meter into centimeter. I am changing centimeter into meter. For converting centimeter into meter, you have to divide by 100 because you know that 100 centimeter equals 1 meter. So 60 divided by 100, you can divide by 20 table. 23s are 60, 25s are 100, so 3 by 5 meter. Height also given, that is height of the overhead tank, that is 105 centimeter. You can change that centimeter into meter. Once again divide by 100 because 100 centimeter equals 1 meter. Here you can cancel by 5 table, 21 times 20 times, so 21 by 20 meter. So you are asked to find out the volume of the water left in the sump after the overhead tank is filled with water from the sump. Initially the sump was full of water. Now volume of the sump. Volume of the sump, that is equal to, from the sump some amount of water is transferred to the tank, cylindrical tank. So volume of the cylindrical tank after transferring some amount of water to the cylindrical tank, some amount of water is left in the sump. So amount of water, that is volume of the water left in the sump. So together is volume of the sump. Again I tell you, total volume of the sump equals volume of the cylindrical tank, because some amount of water is transferred to the overhead tank from the sump. So that is in the shape of cylinder. Then after transferring some amount of water is left in the sump itself. So volume of the water left in the sump. For example, so volume of the sump, total sump, the capacity is 10 meter cube. For example, I am telling 10 meter cube. Here cylindrical tank capacity is 8 meter cube. Here the left out is 2 meter cube, correct? 8 meter cube. Then 2 meter cube water is left in the sump itself. 8 plus 2, that is equal to 10 meter cube. Okay. Now volume of the sump in the shape of a cuboid. Cuboid volume, you know that LBH, that is equal to volume of the cylindrical tank, cylindrical volume, that is pi r squared h, plus volume of the water left in the sump, right as it is. Volume of the water left in the sump. Therefore, you can retain the volume of the water left in the sump in the right hand side. When this pi r square h comes to the left hand side, you will be getting minus pi r square h. So, LBH minus pi r square h, that is equal to volume of the water left in the sump. So, you can write like this. It implies volume of the water left in the sump equals LBH minus pi r square h. LBH minus pi r square h. Here h, here also h. So consider them as h1, h2 or h1. So I consider this is h1. So which one is h1? Overhead tank, cylindrical tank height as I consider as h1. So cylindrical tank I consider as h1. Here also h1. Now you can substitute the values LBH. So LBH whole meter only 2, 1.5 and 1. 2 into 1.5 into 1. That is equal to 2 into 1.5 into 1 minus pi r square h1. Pi value 22 by 7. R square. Here R represents a radius of the cylinder. The radius of the cylinder is 3 by 5. So 3 by 5 into 3 by 5 and the height is 21 by 20. Pi value 22 by 7. Radius 3 by 5. Again 3 by 5 because R squared into H1, that is equal to 21 by 20. Now we have to simplify. That is equal to 2 into 1.5, that is equal to 3. 3.0. 1.5 into 2, that is equal to 3.0. 3.0 into 1 is 3 only minus. Here we can simplify. We can cancel 7 and 21 by 3 times. Then here 2 table 11 times. Here 10 times. That's all. Then 11 into 3 into 3 into 3. 3 3s are 9, 3s are 27. 27 into 11. I do the calculation here. 27 into 11, that is equal to 27, 297. 297 divided by 5 5s are 25. 25 into 10, that is equal to 215. That is equal to 3 minus, you have to divide 297 upon 250. 297, do it here. 297 divided by 250 equals, can divide by 250 one time only. 1 into 250, 250, balance 7, 4, 2 minus 2, 0. Put the point here, 0. Once again one time, 1 into 250 is 250. 0, 7 minus 5, that is equal to 2. 2, here 0, how many times? Approximately 8 times. 8 into 0, 0. 8 5s are 40, balance 4. 8 2s are 16 plus 4 is 20. 2000. 0, 0, 2 minus 0, 2. 2 minus 2, 0. Again 0. Again 8 times. So 8 into 250 is 2000. Got the remainder 0. So 1.188. Now you have to subtract 3 minus 1.188. 3 means 3.000. Then 1.188. You have to subtract. If you subtract, have to borrow here. 3 becomes 2. This 0 becomes 10. This will be 9. It will be 9. 10 minus 8 is 2. 9 minus 8 is 1. 9 minus 1 is 8. And 2 minus 1 is 1. 1.812. So what's the answer? 1.812 meter cube. Okay. Or You can write the answer in centimeter cube also. The book answer given is in centimeter cube. It is absolutely correct. If you want to get the book answer, you have to do some modification. For changing meter cube into centimeter cube, you just write 1.812 into for 1 meter, that is equal to 100 centimeter. So 100 into 100 into 100 centimeter cube. So why you are multiplying 100 for 3 times? We have meter cube. 3 meters are there. Meter, meter, meter. Meter into meter into meter. For converting meter into centimeter, each and every times have to multiply by 100. So we have power 3. So 3 times you have to multiply. So 100 into 100 into 100. So automatically is converted into centimeter cube. So you write the reason, since 1 meter that is equal to 100 centimeter. Now we can multiply here 1.812 into 1, here double 0, here double 0, here double 0. If you multiply, you will be getting 1 followed by 6 zeros. Okay, that is 10 lakhs. In 10 lakhs, how many zeros are there? 6 zeros are there. So that while multiplying, you can move the decimal point towards right hand side by 6 places. 6 places means, look at that, we have the decimal point here. From that 6 places, 1, 2, 3, 4, 5, 6. So decimal point here it is. Now it has been moved to 6 places. 1, 2, 3, 4, 5, 6 centimeter cube. This is the book answer. Actually 281200 is given. This is the correct answer. Book answer is wrong itself. So problem number 5 is completed. So I will be teaching problem number 6 in the next video. Thank you, children.